Megacorp's public procurement API is getting hit two ways at once. Someone is stuffing SQL code into the query strings, and at the same time, a flood of junk traffic is trying to bury the whole thing. Reach for one service to stop both, and you'll stop neither. The right answer depends entirely on which layer the attack lives on. This is Cloud Architect Path. No fluff. Let's go. By the end of this video, you'll be able to match any internet-facing attack to the exact Amazon Web Services service that stops it. We'll cover WAF for web exploits, Shield for volumetric floods, Network Firewall for everything inside your VPC, and Firewall Manager to govern it all. The whole thing hinges on one idea: identify the layer of the attack before you pick the tool. In episode 9, we drew the line between security groups and network ACLs. Security groups are stateful, allow-only firewalls wrapped around a single instance. Network ACLs are stateless filters at the subnet edge, with both allow and deny rules. But notice what neither of them can do. Neither one can read the actual contents of a packet, and neither can filter by domain name. That gap is exactly where today's services come in. 5 terms anchor everything in this episode. Get these clear now, and the rest clicks into place. Amazon Web Services WAF is the web application firewall, working at the request level. It reads individual HTTP and HTTPN, HTTPN, HTTPS requests and decides what to do with them. A Web ACL is the container that holds your WAF rules and applies that allow, block, count, or challenge decision to each request. Amazon Web Services Shield operates a layer down. Instead of reading requests, it absorbs raw volumetric floods at the network and transport layers before they even become HTTP traffic. Amazon Web Services Network Firewall goes wider still. A stateful firewall covering all traffic across a VPC, not just web protocols. And Amazon Web Services Firewall Manager sits above all of them, pushing consistent firewall policies across every account in an Amazon Web Services organization from a single place. Here's the core problem. The open internet doesn't send you one flavor of attack. SQL injection and cross-site scripting right inside individual HTTP requests, they're hidden in the content. Credential stuffing bots take a different approach, hammering your login endpoint with sheer request volume. And volumetric denial of service floods aim lower still, trying to exhaust your bandwidth and your connection tables before a request ever gets parsed. No single control answers all three. The layer the attack targets is what decides which tool you reach for. So here's the mental model that ties the whole video together. At layer 7, the HTTP layer, Amazon Web Services WAF inspects the content of each request. That's where SQL injection, cross-site scripting, and rate limiting live. Down at layers 3 and 4, the network and transport layers, Amazon Web Services Shield absorbs volumetric floods before they ever reach your app. Inside the VPC, spanning layers 3 through 7, Network Firewall does stateful deep inspection of any protocol at all. And wrapping around everything, Firewall Manager enforces all of these centrally across your whole organization. Keep this map in your head, and every scenario answers itself. Let's start with WAF. This is the only Amazon Web Services service that actually reads the content of each HTTP request. It's the request inspector. You configure it with a Web ACL, which groups your rules together and decides what happens to each request. Allow it, block it, just count it, or throw up a CAPTCHA or a challenge. You attach that Web ACL to a front-facing resource, a CloudFront distribution, an application load balancer, API gateway, AppSync, a Cognito user pool, or App Runner. And it can make its decision based on almost anything in the request: the source IP, the headers, the query strings, the URI, even the request body. The Amazon Web Services documentation puts it cleanly. WAF monitors the HTTP and HTTPS requests forwarded to your protected resources, and then your resource responds one of three ways: with the content the caller asked for, with a 403 forbidden if the request is blocked, or with a custom response you define. Notice the key phrase there: requests. WAF operates on individual requests, one at a time, reading what's inside them. That's the whole identity of this service, and it's what separates it from everything else we'll cover. Now here's a detail that trips people up. A Web ACL has a scope, and it's either global or regional. A global Web ACL is created in the North Virginia region, and it attaches only to CloudFront distributions, nothing else. A regional Web ACL lives in the same region as your resource, and it attaches to load balancers, API gateway, and AppSync. The catch is that these don't cross over. A global ACL cannot protect a load balancer, and a regional ACL cannot protect CloudFront. When a scenario names CloudFront, think global. When it names an ALB or API gateway, think regional in that resource's region. You don't have to write every rule yourself. Amazon Web Services maintains pre-built collections called managed rule groups, and it updates them automatically as new threats appear. The core rule set covers the OWASP top 10, including cross-site scripting. The SQL injection rule set is tuned specifically for advanced injection patterns. There's a known bad inputs group that catches exploits like log4shell, and an IP reputation list that blocks sources already known to be malicious. One tip from the field: always run a new managed rule group in count mode for a day or two first. That lets you catch false positives before you flip it to block and accidentally turn away real customers. Here's a decision rule worth burning into memory. SQL injection and cross-site scripting are the two classic Layer 7 attacks, and both of them stored inside the content of an HTTP request. That means the answer is always off. It is never shield, and it is never network firewall. If a scenario mentions injecting SQL into a query string, or slipping a malicious script into a form field, your hand should move straight to WAF without hesitation. WAF has a second trick that isn't about reading content at all. It's called a rate-based rule, and it works by counting. It tallies up requests that share a key, by default, the client's IP address, over a rolling 5-minute window. When one source crosses your threshold, WAF takes action. Block it, count it, or hit it with a CAPTCHA or challenge. This is your primary weapon against credential stuffing bots and HTTP floods, where the problem isn't what's in each request, but how many are coming. And the floor is tight now. You can set a threshold as low as 10 requests per 5 minutes, which lets you clamp down on even slow, targeted abuse. Picture a subway turnstile with a speed governor built in. It lets normal commuters through at a normal pace, no problem. But if one person tries to shove through 50 times in a minute, it locks them out. The turnstile doesn't care what that person looks like. Reading their appearance is WAF's content inspection job. The turnstile only cares how fast they're pushing. That's the difference between a rate-based rule and a managed rule group. One counts frequency, the other reads content. Let's lock in WAF before we move on. It inspects HTTP content, so it blocks SQL injection and cross-site scripting using those managed rule groups. Its rate-based rules throttle abusive callers by frequency, not content. Scope matters. Global for CloudFront, regional for load balancers and API gateway. And one boundary to remember: WAF does not support network load balancers because those operate below the HTTP layer WAF needs to read. If a question hands you an NLB, WAF is the wrong answer. Now let's talk about floods, and that means shield. The good news is that the baseline is already handled for you. Shield standard is always on, automatic, and free for every single Amazon Web Services account. It protects against the common Layer 3 and Layer 4 floods, SYN floods, UDP reflection attacks, that whole family. Amazon Web Services, over 99% of these infrastructure layer attacks are mitigated automatically in under 1 second, right at the edge. And here's the part people forget on the exam. There is nothing to enable. No console, no configuration, no cost. If a question asks how to get basic DDoS protection at no charge, the answer is simply that Shield standard is already running. Amazon Web Services draws the line in one sentence. Use WAF to protect against attacks like SQL injection and cross-site scripting. Use Shield as a managed DDoS service for common attacks at the network and transport layers. That's the whole distinction. Right there in the official decision guide. WAFs reads the words inside a request. Shield absorbs a flood of packets aimed at the network itself. 2 different jobs, 2 different layers. For high-value workloads, there's a paid tier called Shield Advanced. It runs $3,000 a month per organization on a 1-year commitment. What do you get for that? Enhanced detection for larger and more sophisticated attacks. Automatic application layer DDoS mitigation, which it does by deploying WAF rule groups on your behalf during an attack. And 24/7 access to the Shield response team, a group of Amazon Web Services DDoS experts. One important qualifier there, to actually engage that response team, you also need a business or enterprise support plan. The subscription alone doesn't unlock the humans. One of the headline features of Shield Advanced is cost protection, and the exact wording matters here. If a DDoS attack forces your resources to scale up and spikes your bill, Shield Advanced offers cost protection against those spikes. But read the fine print. That protection comes in the form of Amazon Web Services service credits, not a cash refund. So when a scenario mentions protecting against a runaway bill during an attack, that's Shield Advanced. Just don't imagine Amazon Web Services mailing you a check. It's credits against your account. Think of it this way. Shield Standard is the smoke alarm every building gets by law. It detects common fires automatically and trips the sprinklers, and no human ever has to get involved. Shield Advanced is the paid fire department subscription. You get bigger suppression capacity, a team of firefighters who call you proactively the moment the alarm trips, and insurance reimbursement, those service credits, if the fire actually causes damage. Most buildings do just fine with the smoke alarm, but a high-rise hotel full of valuable guests happily pays for the fire department. Same logic for a revenue-critical, internet-facing workload. Here's the misconception that snags engineers. Shield does not inspect your HTTP. It never parses a SQL query. It never examines an XSS payload, and it never reads a request header for injection attacks. Shield's entire job is absorbing volumetric floods at the network and transport layers. Yes, Shield Advanced can trigger automatic WAF rules during a detected Layer 7 attack. But that's WAF doing the inspecting, not Shield. Keep the roles clean. Shield absorbs volume, WAF reads content. Let's run Megacorp's dual attack through the decision. Start at the top with one scenario. What is the attack? Branch left, and it's SQL injection or cross-site scripting inside a request that routes straight to WAF. Branch right, and it's a volumetric UDP flood that routes to Shield. And because Megacorp's procurement, a PI, is a public web workload facing both threats at once, the 2 branches converge at the bottom. You run WAF and Shield together. Same scenario, 2 attacks, and neither service alone was ever the full answer. Here's why these 2 aren't rivals. They're partners. When Shield Advanced detects an application layer DDoS, it automatically deploys WAF rule groups to fight it. The 2 services are literally wired to cooperate. So for a high-value internet-facing web application, The gold standard answer isn't WAF or shield. It's both, working together, WAF handling the layer 7 filtering, shield absorbing the network layer flood. Quick checkpoint before we go deeper. WAF reads the HTTP words. It handles SQL injection, cross-site scripting, and rate limiting. Shield absorbs the flood, mitigating volumetric attacks at the network and transport layers. Standard is automatic and free, while Advanced adds cost protection credits and that response team. But everything so far has been about web traffic hitting your edge. What about all the other traffic moving inside your VPC on protocols that aren't even HTTP? That's the gap we fill next. Amazon Web Services Network Firewall is a stateful managed firewall with intrusion detection and prevention built in. Unlike WAF, it isn't limited to HTTP. It does deep packet inspection of any protocol on any port. It filters traffic right at the perimeter of your VPC, traffic flowing to and from your internet gateway, your NAT gateway, a VPN, or a direct connect link. Under the hood, it runs the open source Suricata engine, the same intrusion prevention technology used across the industry. So this is your tool for everything security groups, NACLs, and WAF simply can't see. That phrase, stateful, managed for your VPC, carries more weight than it first appears. Stateful means the firewall tracks the full conversation, not just individual packets. And the VPC scope is the key distinction. Network firewall sits at the perimeter of your entire virtual network, inspecting everything flowing in or out, not just traffic reaching a single load balancer or instance. No other service in this video operates at that level. Remember from episode 9 what security groups and NACLs actually do. They filter by IP, port, and protocol, and that's the whole toolkit. No payload inspection, no domain name filtering, no intrusion prevention signatures. Network firewall picks up exactly where they run out. It inspects the payload deep inside the flow. It runs Suricata IPS rule signatures. It filters by domain name using the TLS server name or the HTTP host header. And it controls east-west traffic between subnets plus outbound egress. When a question says security groups and NACLs aren't enough, this is the service they're pointing you toward. Network firewall works in 2 passes, and it mirrors how enterprise firewalls have always worked. First come the stateless rules. They look at each packet on its own, against the 5-tuple of source and destination IP, source and destination port, and protocol. Each packet is passed, dropped, or forwarded on for deeper analysis. That forward step hands the interesting packets up to the second pass. Now the stateful rules take over, evaluating packets in the full context of their connection. This is where deep packet inspection and the Suricata signatures do their work. And finally an action lands. Allow the flow, drop it, or raise an alert. Fast filter first, heavy inspection second. Here's a defense teams almost always overlook: filtering traffic on the way out. With Network Firewall, you build a domain allow list that restricts outbound traffic to approved destinations only. It identifies those domains straight from the TLS server name or the HTTP host header, so there's no separate DNS lookup needed. A real example from the Amazon Web Services security blog. A team locked down their EKS pods so they could only reach a small set of allow-listed host names, and everything else was dropped by default. The payoff is huge. Even if an attacker compromises a container, they can't ship your data off to some server they control because the firewall won't let that connection out. One analogy makes the whole distinction click. WAF is a bouncer stationed at the front door of your web app. He reads HTTP headers and bodies and turns away anything that looks like an injection or a script attack. Network Firewall is the building-wide security system, wired into every corridor. It sees every packet regardless of protocol. It can catch a maintenance worker trying to sneak a server out the back. That's egress filtering. and it raises an alarm on any suspicious pattern, not just the question of whether something is a valid HTTP request. One guards a single door, the other watches the whole building. Now the boundary that catches people. Network firewall does not attach to a load balancer. It lives in the VPC routing path, inspecting traffic as it flows through the network, not at a load balancer's listener. So if a scenario describes an application load balancer that needs protection against web exploits like injection or scripting, that is a WAF job, full stop. Network firewall and WAF cover different territory, and swapping them is one of the most common wrong answers. So far, every service protects one workload at a time. But what if you've got dozens of accounts? That's where Firewall Manager comes in. From one central administrator account, you define policies that apply across your entire Amazon Web Services organization. It manages Web ACLs, Shield Advanced Protections, security groups, and network firewall policies, all from one place. And here's the magic. Those policies automatically apply to new accounts and new resources the moment they appear. It solved the drift problem, where someone has to remember to manually attach a WAF ACL in every single account, and a brand new account sits unprotected until somebody notices. Amazon Web Services describes it perfectly. With Firewall Manager, you set up your protections just once, and the service automatically applies them across your accounts and resources, even as you add new accounts and resources. Think of it as a corporate security memo that enforces itself. Instead of headquarters sending a note that says, "Please install a deadbolt," and hoping each office complies, Firewall Manager sends a robot that installs the deadbolt in every office and checks every new office on its very first day. Firewall Manager has 3 prerequisites, and one of them is famously easy to forget. First, you need Amazon Web Services organizations with all features enabled. Second, you designate a Firewall Manager administrator account. And third, this is the one people miss. You must have Amazon Web Services config turned on in every member account and every target region. Without config, Firewall Manager can't detect new resources, so they never get protected. On cost, budget roughly $100 per policy, per region, per month. That adds up fast across many regions, so the practical advice is to consolidate related rules into fewer, broader policies. Let's clear the 4 misconceptions that cost people points. First, WAF does not stop volumetric DDoS. It can rate limit HTTP, but absorbing a bandwidth flood is Shield's job. Second, Shield never inspects HTTP payloads. It doesn't parse request content at all. Third, WAF does not attach to a network load balancer. It supports CloudFront, application load balancers, and API gateway. And fourth, Network Firewall does not attach to a load balancer either. It sits in the VPC routing path. Get these 4 straight, and the distractors stop working on you. Here's the whole video on one cheat sheet. SQL injection or cross-site scripting goes to WAF. An HTTP flood, rate limiting, or bot traffic also goes to WAF. A volumetric DDoS, SYN, or UDP floods goes to Shield. Anything non-HTTP, any intrusion detection and prevention, or egress filtering goes to Network Firewall. And central enforcement across an entire organization goes to Firewall Manager. One last note, everything here is preventive edge defense. It blocks or absorbs attacks. The detective services that spot threats after the fact are a topic for the next video. Carry 4 rules forward. Identify the layer of the attack first, then choose the service. That single habit answers most of these questions. WAF reads the HTTP words, while Shield absorbs the network floods. Network Firewall guards the whole VPC across any protocol, filling the gap security groups and NACLs leave open. And Firewall Manager governs the entire fleet from one place. All 4 preventive defenses. They stop attacks at the edge. Now let's see how well you absorbed all of this with a quick 5-question quiz. All right, time to put your knowledge to the test. Question 1. A company's public API and API gateway is being flooded with SQL injection attempts in the query strings, and at the same time hit with a volumetric UDP reflection attack aimed at bandwidth. Which combination addresses both? Is it A, network firewall for the injection and shield for the flood? B, WAF for the injection and shield for the flood? C, shield for both? Or D, WAF for both? Think about which layer each attack targets before you answer. The right call here is B. SQL injection lives inside the HTTP request, so that's WAF at layer 7. The volumetric UDP flood targets the network layer, so that's shield. 2 attacks, 2 different layers, 2 different services working together. Question 2. A security team wants to attach a WAF Web ACL to protect a single CloudFront distribution. Which scope must the Web ACL use? A, global scope, created in the North Virginia region. B, regional scope, in the same region as the origin. C, either scope works for CloudFront. Or D, a CloudFront-specific scope chosen during setup. Lock in your answer before I give it away. This one is A. To protect CloudFront, the Web ACL must be global scope, and global ACLs are created in the North Virginia region. Regional ACLs attach only to load balancers, API gateway, and AppSync, never CloudFront. Question 3. A high-value streaming platform needs 24/7 access to Amazon Web Services DDoS experts during active attacks, plus billing protection against attack-driven scaling costs. What must be in place? A, shield standard, which includes the response team for free. B, WAF with rate-based rules and cost anomaly detection. C, shield advanced plus a business or enterprise support plan. Or D, shield advanced alone. Think about which constraint matters most here. It has to be C, and here's why. Cost protection through service credits and the Shield response team are both Shield advanced features. But engaging that response team has a second requirement. You also need a business or enterprise support plan. Advanced alone doesn't unlock the humans. Question 4. A team needs to restrict outbound traffic from EKS pods so containers can only reach an approved list of external domains, blocking exfiltration anywhere else over any protocol. Which service fits? A, WAF with a rate-based rule on outbound requests. B, security groups with outbound rules per domain. C, Shield Advanced with automatic mitigation. Or D, network firewall with a domain allow list using the TLS server name or HTTP host. Got your pick? Let's see. If you said D, well done. Domain-based egress filtering across any protocol is a network firewall capability. WAF only inspects inbound HTTP. Security groups can't filter by domain name at all. And Shield handles volumetric floods, not outbound control. Last question. An enterprise with 80 accounts in an organization wants every new load balancer to automatically get a baseline WAF Web ACL with no manual setup. What's required? A, Firewall Manager with Amazon Web Services config enabled in all member accounts and regions. B, a single Web ACL shared across all accounts. C, a service control policy that forces WAF attachment. Or D, identity center permission sets that auto-attach WAF. Pause here if you want more time. The answer is A. Central WAF enforcement across an organization, applied automatically to new resources, is exactly what Firewall Manager does. And don't forget the prerequisite everyone misses. Amazon Web Services config must be enabled in every member account and region, or Firewall Manager can't detect those new load balancers to protect them. And that's web application protection, WAF, Shield, and Network Firewall, demystified. If it helped, the subscribe button is free, and it does more than you'd think for getting these seen. Drop your feedback in the comments. What worked? What didn't? All of it useful. Want a different certification next? I take requests below, and if the pacing or the look could be better, let me know. Catch you next time.